All right. Thanks, Phil. Today we put together a talk about the state of broadband design in Australia. I guess it's pretty topical at the moment, going through a fair bit of change in terms of the NBN and subscribers, and maybe some technologies that are emerging along the way. So we thought we'd just go through what we're seeing from our perspective, and this is what we came up with. So first we got some trends, then we've got the ecosystem, then we've got the technologies that we're looking at, and the use cases around that. So from a global perspective, and I guess evidenced locally, we're seeing a move towards gigabits and multi-gigabit access technologies. I think last year people were talking about XGS-PON, there's been enhancements to DOCSIS and whatnot. There's more and more FWA, there's satellite, everything is going towards higher speeds. And of course, we've got NBN loosening up the connections and access speeds that they're delivering. So if we look at some of the stats globally, we can see on the top left there, we're sort of, I think if you look at from a country perspective, 80th or 90th in the world in terms of access line speeds. That's probably going to increase with these moves from the increase of those speeds. So what can we expect from an average speed? We're going to expect that to go from maybe that 5 to 6 sort of megabits that you talk about at peak speeds for users, maybe doubling in a short period of time. So if we look at the bottom right, that's the ACCC sort of numbers that measure the NBN. About 60 to 65% of that is sub 50 megabit at the moment, but maybe over the next 2 years with the push towards the higher access speeds, we're going to see that grow quite quickly, not just the standard sort of year-on-year growth that we've been seeing so far. So from a technology perspective also, when we look at what's happening around the world, the subscriber termination and management models for these sort of customers are changing too. So let's talk about distributed models that's been there for quite a while. You'll see people talk about cloudified, and then maybe some integration and disaggregation via 5G or via CUPS from a subscriber termination point of view. Of course, the NBN is not everything. There's lots of other things going on. FWA I mentioned, satellite, and all the other local fibre sort of access providers as well. The other thing that's probably a bit more unique in Australia is we're getting more and more regulatory attention, and that's probably only going to increase in terms of what gets measured and how we have to provide reporting to everyone. So if we look at the numbers there as well, I mean globally and here as well, there's a big effort to get rid of the copper in the networks. There's a big push towards, I guess, fibre to the home or fibre to the premises that's going on. There's a lot of talk around FWA and satellite. So that's what the top left sort of graph shows. There's a lot of growth in those areas, but the bottom sort of left graph shows predominantly the access methods being used to get all these speeds, the fibre there. We can see that satellite and FWA itself is coming off very low bases. HFC cable's sort of steady, maybe declining a little bit, and copper itself is the big, I guess, loser in that space. If we look at the bottom right graph, we're sort of mirroring that. We've had the MTM, I guess, with NBN there, but there's a lot of announcements there and a lot of work and investment to shift away from the fibre to the node and fibre to the curb technologies onto fibre itself and a bit more FWA. If we look at what's happening from a demand driver point of view, we get ever increasing demands from gaming services, streaming services. That's driving the traffic growth. More and more Internet of Things, so home automation. Everyone I talk to has more and more devices in their home that are connected to the internet or apps or whatnot. That's probably driving a lot of session volume through things like CGNAT or other things that need to remain session aware. And then there's a lot of hype around AI. When I speak to people they're not really seeing maybe that as a huge traffic driver yet. I think we're seeing a lot of text-based AI, so ChatGPT and other sorts of things, replacing search, those sorts of effects. But what's being talked about maybe at a global level is more video-based AI interaction, and that potentially driving traffic there as well. If we look at the ecosystem, I think in Australia we see a fair bit of talk around the CPU side. So obviously if the line speeds are increasing, service speeds are increasing, we need to match that in the home. So everybody's got a story about Wi-Fi and how that affects the actual service quality. We've got the aggregation networks and the resiliency around those that we need to, I guess, build up to be able to deliver the services from the access side. We've got the subscriber edge portion itself, which is what we'll focus a bit more on, and then all the supporting services there as well. I think anything that we do to change anything generally has an effect on something else in the system. So just changing the speed at the access side, obviously we need to cater for that in the aggregation and the edge. Changing the authentication methods and other bits and pieces can have on-flow effect in the system. So we need to approach it all as a system as opposed to just individual components to get the full benefits of any of the changes we make. So looking further into the subscriber edge portion, I think we see these sort of deployment options and design option choices. I think most people are very aware of the centralised sort of distributed methods of deploying things there. So that's very common in Australia, where we have in each capital city a bunch of BNGs, maybe geo-redundant sites. We may be doing that with big modular boxes, or these days, I think more and more, we've sort of seen this move to this distributed or smaller boxes or pools of smaller boxes in a scale-out sort of architecture. And we see that get pushed out regionally if there's enough drive from a customer point of view to do so. So there's been a lot of benefits, and I think people have taken advantage of that. It's cost effective, provides better resiliency, lower blast radius sort of stuff. So I think a lot of people here are probably doing that today, but there's still a mix going around. And when I speak to our global peers, it's a pretty common theme as well. So still a fair bit of centralised and distributed architecture out there, scale out. But we're starting to see more of disaggregation come into play, cloudified sort of bits and pieces in terms of maybe using fabric or pod architectures to connect up physical leaves. You see people talking about containerised or virtual BNG sort of subscriber termination as well. And there's been a lot of work around standardisation in the Broadband forum to try and move CUPs forward. So disaggregating the management plane and that integrated BNG into control plane and user plane functions. And that's very, I guess, common terminology in mobile land as well. So the effect of that is we're able to also then from there be able to maybe sub out the control plane from a fixed point of view and use a mobile control plane. So I think this has been getting talked about for a long time. If you look online 2016 and before, there's a lot of stuff around OpenBNG, Deutsche Telekom, a lot of the European providers have been talking about it. I don't think they've really gotten there in volume yet, and that's probably because of competing priorities. It's nice to be able to disaggregate things, but if there's no real benefits or it's very hard to maintain, it's not necessarily being deployed yet. But now with the standardisation maturing, and we'll talk about that a bit more later, we are seeing people start to go in that direction. Convergence from the perspective of using a mobile control plane to replace the fixed control plane is starting to look attractive for some people if they don't have a lot of fixed access. So substituting the fixed access with the mobile access and making that look the same is something that's happening more in emerging markets. Being old and grumpy, we often have conversations about PPP and DHCP. I think most people have moved towards DHCP-based AAA and access in Australia, but we still have a lot of legacy PPP. I think when we enhance technologies, we often get a small benefit going forward, and then we have to go retrofit the new technology with a lot of things that the old technology had. So with PPP, we obviously had a lot of inbuilt authentication. We had the inbuilt authorization. We had the inbuilt accounting. DHCP, well, we got rid of some of the dependencies on the access side. We had to enhance that, going back and putting forward all the authentication functions in and matching that up to the legacy sort of management systems there. The other good thing PPP was good for is, each subscriber was in a signal tunnel. We understood the state of it very well. With DHCP, we don't necessarily understand that, so we're dealing with different half-lives of releases and things like that. So it's, I guess, just important to understand we have to deal with both of these things quite often, but it does have an effect on our management and failover of those systems. If we look what's been happening globally around that area, some markets are way ahead with DHCP, some operators are way ahead with DHCP. Places maybe with lower speeds still dependent on PPPoE, and we see a sort of blend across all the regions there. So with that, I'll pass it on to my colleague Premesh, and we'll go through resiliency and technologies.
Thank you, Travis. Good morning, everyone. Hope you are having fun so far. I'll be talking about resiliency and emerging technologies, and of course, we'll talk about the use cases. When I talk about resiliency, there are two parts: service availability and operational protection. Let me talk about my personal use case during dial-up time. If my home internet would not work, I'll just go out for a walk, come back in 20 minutes time, and hopefully everything is back normal, right? But now, if my home internet is not working, even for 2-3 minutes, my garage might not work. I would not be able to open my lights, right? Hence, resiliency is a key. When we talk about broadband, resiliency makes more sense. We just heard how we take care of the access part, right? Resiliency for a BNG world is not just a box-based resiliency. We need to take care about the access part as well as core part. CGNet. If something is not working on CGNet, subscriber will not get the IP, right? If my access part is down, subscriber might need to reconnect. Hence, resiliency is a key, but we all know it's an economical matter, right? We need to trade off between the protection and the cost. Resiliency would be stateful or stateless, right? What we are seeing with most of the operators they are still using stateless. Stateless is where a backup node doesn't need to worry about the session happening on a master node, right? PPPoE and DHCP. PPPoE follow a reconnect model, wherein in DHCP, if my master is down, the users will get a default profile. And that default profile means they would not be able to get the throughput what they have purchased for. And that default profile would be there for a time when their session expires. Which means for an operator, they need to wait for some time to get all the sessions back to normal, whether they are PPPoE, reconnect, or a DHCP where a user will go back to their normal profile. What we are seeing globally is people are moving, or operators are moving from stateless to stateful. Stateful is where session persistence is a key. Your backup nodes know what's happening on the primary node, how many users are active, and all, right? A stateful can be all the way from one-to-one to M2N model. One-to-one model where there's a one-on-one mapping between your primary and backup node, which means your backup nodes know not only on a control side, but also a forwarding side that how many sessions are there and how to take care of it if there is a failure. It provides a very fast failover, right? But it is expensive. That's where operators are moving, or they look at end-to-one resiliency. End-to-one resiliency works well if there is a single failure. I have a backup node which will take care of everything from a master node. Of course, it would not be as time quick as it would be one-to-one. The challenge comes when there are multiple failures. We don't know what will happen if second failure will happen. That's where operators are moving to M2N. When we talk about M2N, it's more about a blast radius as well, where instead of using two big boxes, they can have multiple boxes, taking care of smaller subscriber base. M2N provide the resiliency, which is quite comparatively to one-to-one, but at the same time, it does take care of multiple failures. It's cost effective as compared to one-to-one, but it's more redundant as compared to one-to-one. Now we have looked at resiliency. Let's move on to the emerging technologies. And this is a recap of what we have seen earlier. Operators are looking at these technologies because they want to meet the demand for low latency, scalability, and service agility. And I'm very excited with what's happening with this broadband world. I will spend some time onto each of the technology, a deep dive, and also we'll talk about a use case, what's happening globally. Cloudified. When I look at cloudified, the two key points come into my mind. Number one, a data center style spine and leaf fabric architecture. And second is a possibility to use virtualized or containerized service leaf for BNG. Cloudified in BNG is a combination of both. An operator can use spine and leaf architecture, and they can have a mix of different BNG leaves. It can be all the way the traditional big box to a smaller compact form factors. And of course, for future, it can be a virtualized or a containerized service leaf. Cloudified provide a benefit to an operator because now they can scale out. They can have more smaller box as compared to multiple or a big giant box. They can have a pathway to move to the virtualized or containerized broadband. At the same time, with cloudified, now operators are more closer to a subscriber because latency is a key for multiple operators and for many of us using at home, right? In cloudified, the subscriber connect via OLT and DSLAM to the access leafs, and then access leafs use EVPN overlay to connect from access leaf to BNG leafs via spine and leaf. Let's look at the use case from Tier 1 provider in USA, who is using spine and leaf with SR MPLS to provide PPPoE and DSCP services to their end customer. They are having end-to-end resiliency and redundancy all the way from OLT to their BNG as well as to their core network. A OLT would be connected via lag and using EVPN ESI to provide active backup resiliency. Your service leaf would connect to your BNG via EVPN overlay, pseudo-wire head and terminate, which means that they have an active and standby. Using ALQ, they are actually providing a stateful resiliency. They have 100 plus BNG in a service leaf, and they are growing fast. Again, a scale out or time to market is a key here. Let me move from cloudified to disaggregated. BNG cups. Control and user plane separation is one of the emerging broadband architecture. And we all know broadband forum. Standardization activities going on via broadband forum. TR459 and WT474. With TR459, issue 3, which was delivered earlier this year, and the team are working aggressively to deliver issue 4, hopefully end of this year. And they are also working on WT474 for service steering capability. On the left is what BNG cups looks like. What actually is being done is a big box of BNG is broken into two separate parts, control plane and user plane. Anything related to the forwarding is part of a user plane. A box on the left, down one, is a user plane, wherein a box in middle is a management plane. Anything brain signaling related would be a control plane. As we have seen in ecosystem, a support service like AAA, orchestration, DSCP are management plane, a box on the top. Operators are getting a distinct benefit with BNG cups because now they can independently scale their signaling as well as their forwarding plane. Scale out is a key here. Let's look at a tier 1 provider in EMEA who have BNG cups deployed in their network. They are getting a great functionality called geo redundancy with BNG cups. They have control plane configured or defined in site 1 as well as in site 2 who are geographically on a distant state. And hence they are giving or providing their users a stateful and stateless resiliency. A stateful when there is a failure in one location, one site, intra-site, a user will move from one user plane to another user plane. But stateless, which means they need to reconnect if they are moving from site 1 to site 2. They are also achieving a intelligent load balancing. And that's the benefit of BNG cups, where a control plane can define based on the scale, the size, and the type of a user plane where to terminate the subscribers. They can terminate subscriber on multiple user plane and yet giving a resiliency and redundancy to a subscribers. They are using segment routing to have their user plane, control plane, inter and intra-site connected using BNG and segment routing. Let me move from disaggregated to converge. Converge is where the things get interesting because two great technologies, broadband and mobile, they merge together. The picture on the left is a standalone BNG service, which we all know about. But the picture on the right, converge edge with wireline wireless convergence, is something which would be coming fast, but is still future. Let me say why it's still future and it's not yet here. As all the great invention need to be done for not only on one single box, but an entire ecosystem has to be upgraded. The same with wireline wireless convergence, where your CPE has to be upgraded or at least capable of not only understanding fixed network, but also to understand 5G. That's called 5G RG routing gateway. The 1 second from the left is fixed wireless access, which is deployable or it's being deployed not only globally but also in Australia market. A fixed wireless access is a logical step toward a wireline wireless convergence, where operators are using packet core, it can be a 5G or a 4G network, to transmit the broadband traffic subscriber from wireless to a BNG for broadband services. It can be a PPPoE or DSCP. The one in the middle, which is wireline evolution, is a converged core where a 5G core would provide not only a 5G service, but also it's capable of providing a broadband-based service. Let's look at the use case from tier 1 providers in USA and US and APAC for fixed wireless access. The diagram in left and right both are using fixed wireless access with multi-dwelling unit to achieve faster time to market and hence getting a new subscriber base where they don't have fiber reachability. The picture on the left is a tier 1 provider from USA who is using private spectrum or radio while millimeter wavelength to provide a subscriber where subscriber would be terminated on a VLAN on a BNG, wherein the diagram on the right is a tier 1 from an APAC who use 5G core, packet core, and use a soft GRE over a packet core to transmit a PPPoE and DHCP user on a BNG device. The key part here for both of them would be they don't need to rely on a fiber layout at the end customer end, but at the same time, a faster time to deployment. A fun fact about the tier 1 from APAC is they have deployed or they have 1 million plus new subscribers in 8 months by deploying 80 BNG devices nationwide. With that, let me have Travis back on stage to talk about the takeaways, and we would be happy to take any queries. Thank you.
Thanks, Premesh. So I guess broadband is quite a big area. We try to cover the end-to-end sort of there. There's many other topics. I think IPv6 was coming up. Obviously, a lot of people have got dual stack deployed. I think in mobile networks now today, we see subscribers able to be terminated with pure IPv6 networks. Maybe it's possible for the future in the fixed line area as well. QoS models are sort of changing with higher speeds. There's probably less need for all the scheduling and shaping, and a lot of the over-the-top services can handle, traffic better than when we had lower speeds before. There's also a lot of work around maybe merchant silicon and how that can terminate subscribers. I think it still can't scale as well as we do today with all the classification that we might need there and policy. And there's also a lot of automation that's going on around the broadband stuff as well. So I think in Australia, we're sort of catching up in terms of speeds and feeds. I guess we're copying a lot of the models from overseas. We're getting there. There's more technology options that are available for people to start deploying. They are maturing. I think we saw from the CUP's point of view, the standards are starting to get there. The code base is starting to get there. So over the next couple of years, that'll become an option to provide different scaling options there as well. But we find there's no one size fits all. Everyone here is doing different things or slightly different things, and they all sort of work. So there's a bit more information there in terms of CUPs and QoS models available on the website. But happy to take any questions.